Food is fuel for your body, your mind, and definitely your sport. But let's face it, nutrition is confusing, and the expectations on girls and women to be thin and have a six-pack are exhausting. If you've ever been frustrated with your body, confused about nutrition, obsessed with eating healthy, or guilty when you don't, underate, overate, or overtrained, and overwhelmed with all the pressure, then this podcast is for you. Nutrition can be easy. You can take control of it, but it might start with letting go of control by asking for help and making a change. I'm Lindsay Elizabeth Cortez, sports dietitian and owner of Rise Up Nutrition, where I empower female athletes to overcome nutrition concerns and perform at their highest level, to stop being confused by all the mixed or harmful messages, and finally have confidence in your body as a fierce, fit, and fueled female athlete. Today's episode is brought to you by Orgain. Ever find yourself rushing out the door to get your workout in, rushing back to shower, and not finding time to prepare a proper recovery meal? This is unacceptable, ladies. And as a listener of this podcast, you know how important recovery is for your performance. And it's one of the reasons that as a registered dietitian, I'm often recommending ready-to-drink nutritional shakes or delicious protein powders to quickly mix up as a convenient recovery option. One of my favorite brands to accomplish this is through Orgain. Orgain is a company dedicated to high-quality ingredients to nourish, fuel, and heal your body. Orgain products are certified organic whenever possible, non-GMO, gluten-free, and made without soy. When it comes to sourcing protein, they have both whey-based protein and plant-based protein options. With ready-to-drink shakes, powders, and bars of a variety of flavors, you never have to miss that post-workout recovery again. As an Orgain ambassador and affiliate, you can use my code RISEUP30 for 30% off your first online order. Again, first-time users, RISEUP30 for 30% off. And as a repeat customer and listener of this podcast, you can use the code OA2203 for 25% off all future purchases. Links are in the show notes and codes are there for your reference. Now let's get to the conversation. Hello, fans and listeners. Lindsay Elizabeth Cortez, your host of the podcast, and I'm here today with Professor Keith Baar. Dr. Baar received his bachelor's in kinesiology from the University of Michigan, where he also served as an assistant strength and conditioning coach with the University of Michigan football team. He then received a master's from the University of California, Berkeley, while teaching strength and conditioning, and his PhD from the University of Illinois, where he discovered the molecular signal that causes load-induced muscle hypertrophy. He did his postdoctoral studies on the molecular mechanism underlying the muscular adaptation to endurance exercise under the direction of Dr. John O. Hollisey at Washington University in St. Louis. Professor Baar opened his first lab in 2004 at the University of Dundee in Scotland. In 2009, Keith moved his lab to its current location at University of California, Davis. The Functional Molecular Biology Lab is focused on determining the molecular mechanisms underlying the physiology and functional adaptations of musculoskeletal tissues to exercise, nutrition, age, hormones, and disease. The result of this research is more than 150 peer-reviewed articles in journals from the Journal of Applied Physiology to Nature. Dr. Baar, thank you so much for joining us.
Thank you. Thank you for having me, Lindsay. This is going to be great.
Yeah, I stumbled a few times on reading your intro. It's a mouthful talking about all of it.
Yeah, we put in a lot of big words. We're trying to impress people.
Yeah, well, I'm impressed already. I want my listeners to know that just as a registered dietitian, I've read lots of your research, but your name first appeared on my radar back in 2015. I went to a conference, the Collegiate Professional Sports Dietetic Association, that you presented at. And you presented about your research in which you were able to, and correct me if I'm wrong on any of this, but in vitro use gelatin and vitamin C to basically grow ligament. And this was really super exciting in the sports world of how we might be able to help injured athletes, maybe somebody with like an ACL tear or something like that. And really, I honestly can't remember, maybe just because I was young in my career, but I don't think that people talked about collagen much or even nutrition for injury recovery quite so much prior to that research. So I wanted to start our conversation with with that research and just kind of talk about that a little bit. Where did you even come up with maybe gelatin and vitamin C can help with ligaments?
Yeah, so one of the things that we were doing at the time, as you said, is we make these tissues in a dish. So we could make muscle at the time, and the muscle, little muscles in a dish, we could make them contract and we can make them produce force. And it was all being funded by the NASA and all of these, high power groups that are trying to think about, okay, if we send a spaceship way out into deep orbit, if we have motors and machines that are just made out of metal, then if something happens to them, they can't repair themselves. So wouldn't it be cool if we could make motors that were actually biological, and if they got some damage to them, they could regenerate themselves? So they wanted to actually see whether they could use muscles as a way to drive machines. And so what we were doing was we were building muscles, but the muscles would always fail and pull off of the machine at the interface between the biological tissue and the machine. So what we had to do is we had to figure out how it worked in a person or in an animal. And muscles don't attach to our bones, which are the hard parts, which are equivalent to the machine. They have this other thing called a tendon that goes in between. And the tendon serves as a shock absorber. And so what it does is it prevents the muscle from getting injured. And so what we then started doing is we started engineering little tendons and ligaments to try and understand the biology of these tissues. Because at the time that we started this, and this was back in maybe 2004, 2003, so it was a long time ago. And what we were doing was we were trying to figure out what was going on with these, but nobody had really done much work on it. And so we did our first studies and we showed that a tendon was stiffer at the bone end than the muscle end. So that's going to be really important for understanding how these tissues function. And then when we tried to grow our tendons and our ligaments, I had this wonderful student who's now a associate professor at the University of Edinburgh in their anatomy department, because what she does is she grows these tendons and ligaments. And what she did was she generated the first ligament, which is a tissue that goes from bone to bone and has these connective tissue cells in it. And what we noticed, what Jennifer Paxton and I noticed, was that they wouldn't be very strong until we started adding things like proline and ascorbic acid to the media, which normally you don't have to add for a muscle. So when we added proline and ascorbic acid, what happened is the ligaments got a lot stronger. And the reason for that is that they're made up of this protein called collagen. And unlike most of the proteins within our body, collagen is a unique protein. It's predominantly made of only 2 amino acids. So its sequence is it's this long protein. It's 100 kilodaltons, so it's more than 100 kilodaltons long. But most of the protein is the amino acids glycine and proline. So the sequence is really simple. It's glycine and then any other amino acid that you've got, and then proline. And that just repeats. And it does that because proline is a unique amino acid, and it allows it to form a little triple helix that makes it a strong protein. It's an important protein in our body. It's the most common protein in our body, but it's really got this potential for limitation based on how much glycine and proline. So we found that when we added glycine and proline, we got stronger ligaments in our dish. So I went and looked up, okay, what are foods that are rich in glycine and proline, and naturally gelatin or collagen came up. And that's when we started considering that might be good for humans to build these tendons and ligaments.
Mm-hmm. I had no idea that this started with research funded that had nothing to do with humans at all. Really interesting how it just kind of continued as you continued to learn more. What's interesting too is your research, you did find that the glycine and proline was strengthening the ligaments, and then you were using gelatin.
Yeah.
Can you kind of explain?
Sure.
Go ahead.
So all we did was we went and when we found out that dietary collagen are going to be our best source of these amino acids, then what we started doing was I tried for like 4 years to beg people to do the experiment, and nobody would do it. So it ended up coming down to Greg Shaw and I. So Greg is at the Australian Institute of Sport, and he and I just decided that we would fund it out of our own pockets. And so the easiest and cheapest way to get dietary collagen is just gelatin. The same kind of stuff you go to the store and you just buy to make gelatin. We use like the equivalent of Knox gelatin. He's in Australia, so they have a different brand down there, but same thing. And so the idea was simple. It was just swirl it around and we were using again, because he was in Australia, we had Ribena, which is just it's a little concentrated black currant juice. And it had about 50 milligrams of vitamin C in it. And that's why we were using it. So you'd swirl around this little crystallized gelatin that would never go into solution. You'd drink that down, or you drink down a placebo control, which was maltodextrin. Again, it's just it's a carbohydrate, but it also is a little crunchy little solution. And so we did the placebo 5 or 15 grams of gelatin. We gave it to a bunch of different people in Australia. They drank it. An hour later, they did 6 minutes of jump rope. And the reason that we do that is because what we were trying to do is stimulate collagen synthesis. And what we had found using our engineered ligaments and then moving into humans was that we could find what we call a minimal effective dose of exercise. And after about 5 minutes of exercise, 5 to 10 minutes of exercise, our tendons, ligaments, and bones, they stop adapting. They stop getting the stimulus to say, okay, we need to produce more collagen. And so what we do is we gave the gelatin. An hour later, they jumped rope. They waited 6 hours, and then they did the whole thing again. And so 3 times a day, they would either drink the placebo, 5 or 15 grams of gelatin. And then what we did is we measured in their blood, we looked for the little end of the collagen molecule, because the collagen is going to form these rope-like structures. You don't want that to happen inside the cell. So your cell makes it so that they can't form the whole rope until they get spit out into the extracellular space. And the way that it does that is it puts little ends on it. And the ends just make it so that it can't form that rope-like structure. So you cut off those ends right before you send it out. So you can measure how much of one of those ends you have, and that tells you how much collagen you've recently made. And that's called the P1NP. Okay, it's just an N-terminal peptide.
Okay.
So it's just a bunch of words, but it's just this marker for how much collagen our body's making. And what we found is with the placebo, we actually got a little bit of a stimulus to collagen synthesis just by jumping rope every 6 hours. 5 grams, no real change, but the 15 grams, we saw a doubling of collagen synthesis. And that was the first time that we had seen that when you eat a source of dietary collagen, that actually is going to stimulate collagen synthesis in people.
Amazing. And so would you say, because since then, this was research you did in 2015, and I think the most recent study you were explaining was a little bit more recent than that, right? 2019-ish. So this research really is lining up to bring this to more practical application with kind of this boom we've seen in the collagen industry, the supplement industry specifically. The research is lining up to say, well, if you take 15 grams of collagen and you are training, exercising on some level, then your body will therefore make more collagen. Would you agree with that statement?
Yes.
The summary statement? Okay.
I would agree with that summary statement. Yes.
Yeah.
One of the things that's really important to note is that so far we haven't done the test against a complete, more digestible, more high quality protein like whey protein. So we're currently doing that study right now where we're doing whey protein versus gelatin just to make sure, or versus hydrolyzed collagen, just to make sure that the collagen is having this effect and it's specific to the collagen. It's not just that any good protein is going to increase collagen synthesis.
Yeah, I think that's really important research because I think that's been a big question over these last few years is, do I really need to take collagen or can I just take another protein source? Because collagen is, as we've already talked about, a source of protein.
Exactly. And it's not a great protein for your other tissues necessarily, because muscle, if I want to build my muscle, I want to have good amounts of leucine in the protein. And there's almost no leucine in collagen at all. In fact, in our first study, we measured amino acid appearance in the blood, and leucine actually went down over the period that we were looking at. And if leucine was important for driving the adaptive response like it is in muscle, then it's not going to have a benefit for muscle.
Mm-hmm. That's a really important distinction. And so in your professional, experience, would you recommend that people consider collagen when it is kind of specific that they're trying to strengthen tendons and ligaments where the collagen is most needed?
Absolutely. So it's not a protein that I would consider at all if I wasn't considering my connective tissues. And again, this is really an important component because what happens when we train is that we don't only train our muscles and our heart and all of these systems. We're actually training our connective tissues, and these tissues can get stronger. They can increase their collagen, the amount of collagen that are within those tissues. And it's not just our tendons, ligaments. It's also the matrix that goes around our muscle that allows our muscle to move forcefully effectively. And so there's a huge amount of collagen-rich tissue that is absolutely essential to performance on a variety of different levels. A lot of the people I get into my laboratory are in my laboratory because they're athletes, they got injured, it took them years to get back, and they want to know why it's taken them years to get back. And so that component for, when we look at professional athletes, 60 to 70% of the reason why a professional athlete can't train or compete is because of their connective tissue injuries. Mm-hmm. So, and then if you go above that, then you have muscle injuries that are based on, okay, how stiff was the connective tissue? And then you have a small number of things that are maybe concussions or other components that are contact based. But the majority of everything else, if you're not, if you don't have an upper respiratory tract infection of some sort, then you're out because of a connective tissue problem. And that's why this is a really significant area.
Yeah, it's a significant area for athletes and their performance. Absolutely. Because as you just mentioned, injury is the number one thing that's going to keep them out of playing. It's really interesting. Now, oh gosh, there was something else I was thinking. Oh yes, I remember my question now. I didn't prep you for this one, so hopefully it's okay if I ask. It's just the collagen markets is very confusing even to me. What can you shed light maybe quickly, I don't know, on like this whole collagen type 1, type 2, or like where is it sourced from? Does this matter?
Yeah, the source matters if you are Muslim and you're trying to stay halal, if you have a specific dietary restriction. So you can get a fish skin based collagen that will, if you have dietary restrictions because of religious belief, you can't take, because a lot of the collagens that we see are going to be from pig or from cow sources. So if there's a concern there, then there are different things. As far as type 1, type 2 peptides, we have never seen a difference between any of them. We actually see that our cheap little gelatin on average in a population is about the same as a hydrolyzed collagen. In individuals, most of the individuals are a little bit better on the gelatin. So, wow. So again, it's when we look at the industry and they're talking about all these peptides, or we start with type 2 or you're breaking it down into amino acids and some small amino acid like molecules and maybe a few peptides that are 2 to 3 amino acids long. It doesn't matter. And your body's not going to be able to identify whether that came from a type 1 collagen or a type 2 collagen. So we don't see any reason why there should be a difference between type 1 and type 2. We've not seen a difference when we've done collagen synthesis rates in people. So for me, it's to get something that you can trust. So if you're an athlete who's competing in an elite sport and you're going to have to go through drug testing, you need to get one of the NSF certified ones because, again, these are coming from cows. Most gelatin comes from Brazil. There's going to be the possibility that they're using different substances. I know in Central America that clenbuterol is quite common. If that gets into you because it's in the cow that's been used to generate the gelatin, then there's going to be problems. So outside of NSF certification or specific dietary restrictions, we don't see a difference.
Yeah. And somebody who, like you said, doesn't have the dietary restrictions or isn't a competitive athlete, like maybe just getting the gelatin from the store is cheaper and works just as well. I know we did that after this research came out back in 2015. I was working in a collegiate setting. We did that. We all ran to the grocery store, got our Knox gelatin mix, and we started making these little gummy bites for all of our injured athletes. So, yeah.
And it works just as well. And so what I tend to do is, especially for myself, my family, my daughter, I'll make up a gummy. I'll make it up as an equal part of gelatin and hydrolyzed collagen. The only reason I use some hydrolyzed collagen is because if I had to use all gelatin to get enough of it, it would be like a rock because it would be so tough. So I just use it in a proportion of about 1-to-1. And then the thing that you have to do is make sure that you don't boil the juice that you use because the juice is going to be the source of vitamin C. If you do, then all you have to do is take out a little bit of vitamin C crystal, make sour gummies by rolling your gummy in a little bit of ascorbic acid or vitamin C, and it's just going to give you a little bit of a tang on the tongue. That's basically how they make sour gummies. So it's totally good.
Yeah. We can get real creative with this. Hey fans, I hope you are enjoying this conversation so far, and we'll be back to it in just a moment. But first, I want to pause and let you know that this episode is brought to you by the Female Athlete System of Transformation, aka the Fast Track to overcome disordered eating and use food as fuel to perform at your highest level. The Female Athlete System of Transformation is my unique program and proven systems to guide female athletes to understanding and implementing the proper nutrition for their sport, life, and health. Myself and my team of registered sports dietitians work one-on-one with clients to address their unique needs and counsel them through the nutritional and behavioral changes needed. Many female athletes who resonate with disordered eating, mental guilt around food and body, relative energy deficiency in sport or female athlete triad, amenorrhea, repeat injuries due to negligent nutrition, or frankly, just a lack of knowledge and understanding on their fueling needs, have seen incredible success in the Fast Track. After years of working as a sports RD, I've compiled the most effective ways for female athletes to learn nutrition, be supported, be challenged, and ultimately find their success with fueling as fast as possible. So don't wait another day. Get to your goals faster by joining the Female Athlete System of Transformation. Look in the show notes or head to the website to book a free call and learn more. Okay, now let's get you back to the conversation. Enjoy. Now, going back to injuries and kind of why this is really, why the collagen is really interesting for athletes to kind of help with injury recovery regarding tendons and ligaments. You've also had some really interesting research on injury risk and maybe some differences between male and female because of hormones' role in stiffness and collagen content. So I'll kind of hand this off to you. Can you shed light?
Absolutely. So if we look at injury rate, the most famous one is that women are 4 to 6 times more likely to suffer an ACL rupture than men playing the same sport.
It's a lot.
Okay. It's a huge amount. It's a catastrophic injury that takes a long time to recover. At the same time, women are 80% less likely to suffer a muscle pull. So if you look in European football, women playing at the elite level of European football have 80% fewer groin and hamstring pulls than men playing the same sport. We can explain both of those two things by explaining how stiff the connective tissue is. Because if you have a stretchy tendon, we always say that a muscle pull happens when the tendon is stiffer than a muscle is strong. So if a muscle is really stiff if the tendon is really stiff and the muscle is a little bit weaker, what's going to happen is when I do a movement, the tendon isn't going to stretch. The muscle is going to stretch and I'm going to pull the muscle. In a woman, what we're seeing is that the tendon is stretchier. And as a result, we're getting better protection of the muscle. But because the connective tissue is stretchier, our knee ligaments are stretchier and we get more knee laxity. The greater the knee laxity, the greater the likelihood of an ACL rupture. Okay, so how do we explain this? Well, if we originally went back to our engineered ligament model and we just modeled what happens during a menstrual cycle. We kept estrogen low for 12 days and then we raised it up to physiologically high levels of estrogen at the 13th and the 14th day. And what we found was that the stiffness of our ligaments went down. Our stiffness of our ligaments went down even though we actually got a little bit more collagen. And so our collagen content of our ligament is important for determining stiffness. But there's another really important component, and that's how much the collagens are linked together. So we have an enzyme in our body that links the collagens together. It's an enzyme called lysyl oxidase. And what it does is it just basically links some of the amino acids in the one collagen molecule with the amino acids in the neighboring collagen molecule. And so when they're linked together, they become stiffer. So the higher the activity of lysyl oxidase, the stiffer your tissue is. So one of the things that we did is we looked to see what happened to lysyl oxidase with the estrogen treatment. So 1 day after treating with estrogen, so 24 hours, 50% decrease in lysyl oxidase activity. 48 hours, it was 80% decreased. So that can explain a lot of what we see in the injury risk for female athletes. Stretchier tendons, fewer muscle pulls. Because they have less cross-linking in the tendon, the result is fewer muscle pulls. Less cross-linking in the ligament, more laxity in the ligament, and then we're going to get more ACL ruptures. And so that's really one of the core components of why we see these connective tissue injury differences, but it also underlies a lot of the performance effects.
Yeah. So it sounds like, and in your research, you did it kind of during the high estrogen during day 12, 13, 14. So that's like during ovulation. And I would imagine it would be the same during just when estrogen rises again during the luteal phase of the menstrual cycle. That would be a risk time as well.
To some degree, but it's less of a risk because estrogen progesterone mixes are a little bit protective. So what you see is, and this is, Wojcicki has done this. He's an orthopedic surgeon at the University of Michigan. He did a famous study where he looked at estrogen and he actually measured the number of ACL ruptures. And what he found is it happened about 1 to 2 days after the luteal surge. So estrogen's high for a couple of days. You get more ACL ruptures for those 2 to 3 days when you have the highest estrogen. It's a little bit shifted. So it takes a day to get the decrease in stiffness. And then you're more prone. And then as progesterone rises and estrogen stays relatively high, now that rate comes down a little bit, but it's still higher than at baseline.
Still higher than the follicular phase, but not. So it's really that ovulation or a couple days, a day or so after ovulation where women might be at the highest risk of these injuries.
They are definitely at the highest risk of injury at that period. And there's some really nice work from Schultz where she's taken women over time and she basically pulls on their ACL every couple of days across the cycle. And what she sees is that the ACL pulls further when you pull it during basically at the luteal surge or 1 to 2 days after that. So she's getting more laxity in the knee in those days that are right around that ovulatory moment. And that's again when estrogen's rising.
Yeah. So this is like super interesting. And, you know, in many ways, it's like knowledge is power. So now we're all aware, but is there anything we can do about this as female athletes?
Yeah, it's an absolutely great question because that's the most important thing that we're looking at. And so again, what we're looking for here is we're looking for something because what's happening is lysyl oxidase activity is going down. We're getting fewer crosslinks and the tissue is less stiff. Mm-hmm. So then what you can think of is, can we come up with ways that we can cross-link the collagen in a different way? And is there a way that we can do that using diet? So what we're doing right now is we're exploring a bunch of things that have the possibility or are able to cross-link collagen, but using a different mechanism than the one that's inhibited by estrogen. Okay. And so what we're using right now is we're using a molecule called MSM. It's in a lot of joint supplements. What it does in the joint supplement is supposed to stabilize the collagen molecules. And at least in vitro, when we do it in our engineered ligament models, we actually see an increase in stiffness, both when estrogen is low, but also when estrogen goes up. And so normally what we would see is that estrogen would decrease stiffness by about 20%, 10 to 20%. Then what we see with MSM is the baseline actually goes up a little bit and the estrogen actually goes up even a little bit higher. And so we're now starting to test this in people to see whether the MSM that you would find in a normal joint supplement could potentially compensate for the effect of estrogen on lysyl oxidase.
Okay.
But the other thing that we know works is that we know that women who take an oral contraceptive have a lower risk of ACL rupture.
Oh, yes. I forgot about that. I read that somewhere in your research. And I think this is really interesting to point out because just in what I teach my clients and a lot of the conversations that I've had on this podcast, even, you know, we're talking about the power of hormones and natural hormones. And I've even had some discussion around the oral contraceptive pill and how it's not as helpful for bone health for those potentially, especially for those struggling with bone density or amenorrhea or something like that. But there's always two sides to every story, right? And there are many reasons to consider a variety of different hormone options, be it natural or exogenous. And this is, I think, one thing that is really interesting to say, okay, well, the oral contraceptive pill might actually be helpful when it comes to ligament tendon injuries in women.
I would say that that's definitely a possibility. And again, what we talk about is we talk about the possibility that, because a lot of what you see with with women who take oral contraceptives is that there's increased rate of muscle injury. As we discussed, that could be explained by a stiffening of the connective tissue, decrease in ACLs. So, and it's a little bit longer to do the recovery after a hard session is what we see. But again, that could be due to a little bit more muscle damage. So what we've talked about and what we've kind of written about is the possibility of during the off season, not being on oral contraceptives, allowing full adaptation because you're not doing those aggressive moves that are going to then put you at risk, and basically taking precautions as you go, understanding your cycle and then maybe taking a little bit more precaution around certain points of the cycle. But then as you get into the season, now maybe starting something that's going to, especially if you have a rapid change of direction, sport that you're playing, if you're doing other things where there's a rotational component, where there's going to be greater joint stress, then maybe we would go to something like an oral contraceptive that would change how, change which tissues are going to see the greatest, potential for injury.
Yeah, that's a really interesting idea. And I think that you'd but you could consider your sport, right? So basketball, soccer, rugby, going to be much more high risk. You could consider your personal background. If you've already had one ACL tear, you don't want to go through this again, whereas other sports that aren't as high risk of, a tendon ligament injury quite so much might not consider this, but something to consider for sure.
Absolutely.
Really interesting.
And so one of the things that's happening right now is we're beginning to understand a little bit more of how hormones are affecting connective tissue. And so I told you that estrogen decreases stiffness. The interesting thing is that testosterone has a reverse effect. It actually increases stiffness. And so what you've got this disparity as well. So, and again, even though we talk about male, female, estrogen, testosterone, everybody has both of these hormones, and both of these hormones are really important. And so certain athletic women will have more or less testosterone as well. And so that's going to mitigate, and that's going to play an important role in both their performance ability, because if you have more testosterone, you're going to have stiffer connective tissue. You can develop power faster. So that might be advantageous for many sports. And it also might be protective for a catastrophic injury, but it also would shift where your potential for injury goes. And so it's not as simple as, okay, what we do in the laboratory is, we can keep the estrogen at this exact level and we're going to go up to this level, but there's none of the other hormones. It doesn't, obviously doesn't work that easily in people. And in fact, when you put in testosterone, but we add an inhibitor of the ability to convert testosterone into estrogen, it has a dramatic effect on what happens to the engineered ligaments that we make. So there's an interplay between testosterone and estrogen, both male, female, but also within a single individual. Because when we have high testosterone, we can easily convert that into estrogen through aromatase. So what we're going to do is we're going to have conversion back and forth. Whether we're men, whether we're women, those hormone levels aren't independent. And so it's really important that we understand how these hormones interplay as well.
Mm-hmm. Mm-hmm. Well, I'm soaking in so much information right now. I'm sure all of our listeners are too. The interplay of hormones and injury risk is super interesting, but I think you pointed out a great point that, we all have everything in it, and there's going to be individual levels of how much we have too. And I don't know if this is too far-fetched, but, this is where, blood work, blood biomarker testing, and even hormone testing might even help you. I mean, women can check their estrogen levels throughout their cycle, or check their testosterone levels and just kind of see where they're at with that stuff.
Yeah. If you're a super competitive athlete, it's going to be useful to understand what those hormones are doing, not because they're going to dictate everything, just because there might be some interplay between, if you're a super successful athlete, but you have an injury history, okay, maybe now what I've got is I've got differences in some hormonal levels, and maybe that just should tell me that I should train slightly differently. That I might have to, if I've got more muscle pulls, I have maybe a slightly different ratio of estrogen and testosterone. Maybe I'm going to do more heavy lifting because that's going to protect my tendons from injury, but I'm still going to get the benefit of having the stable knees and other tissues. And then incorporating some of these things into the diet as you would need. So if you know that you've got more changes in laxity in your knees throughout your cycle, then maybe trying to see if there's other cross-linkers that you can get in your diet, something like MSM that cross-links collagen in a different way might be useful for those individuals.
Could we go back to that really quickly, the MSM? What exactly is that? Is that a protein? Is it a...
No, it's a small molecule. It's just methyl sulfur. It's a methyl sulfur group.
Okay, methyl sulfur.
The idea is that either the methyl group or the sulfur group is going to help in the cross-linking of the collagen.
Okay, interesting. And I'm going to have to, I think I actually have seen this ingredient on joint health supplements before and just probably didn't know exactly what it was.
So most of the joint supplements are going to be chondroitin with glucosamine, and then a lot of them will have MSM in there as well. Mm-hmm. And so the MSM is designed to maybe stabilize the structure by cross-linking the collagen molecules. So the idea in a joint supplement is that you're going to have breakdown of cartilage or something, and that the chondroitin and the glucosamine are going to increase the little proteins that hold water, and that the MSM is going to stabilize the collagen molecules so that it's basically the sponge is the cartilage. The water within it gives it the absorbing capacity, and the stiffness of the sponge is going to tell you how much of a cushioning component there is.
Mm-hmm. Awesome. Okay, so another question or topic I wanted to chat about today, I probably should have done it in the beginning. It sounds a little more basic now compared to everything else we've talked about, but it's still quite interesting. Dr. Baar, you and people in your lab were some of the first to kind of discover the pathways to induce muscle hypertrophy, or essentially just muscle growth, and to really distinguish that this pathway is quite different than when we are training our muscles for endurance. And I think that this is something I've known for a while and share with my clients all the time, but I think the general population still gets confused when they're trying to mix training of cardio training and muscle lifting, and then they're wondering why they're not building muscle. So I was wondering if you could sort of briefly explain to our listeners what the mTOR pathway is, and what does that mean for people who are doing different types of training?
Sure. So the idea here is that when we're going to try and build our muscles bigger and stronger, so what we're going to need is we're going to need to increase how much of the muscle proteins that we're making, because that's going to allow us to synthesize more protein than we're breaking down. Think of it like your bank account. If you increase your income without increasing your expenditures, your bank account gets bigger. Same thing we're trying to do. So your income is your protein synthesis, your expenditures, that's the protein degradation. So what we're trying to do with when we're looking to grow a muscle is it's not just down to mTOR protein, but what mTOR does is it regulates our ability to make new protein synthesis machines or ribosomes, or it regulates the activity of the ribosome. So what it's doing when we activate mTOR, especially with resistance exercise, is it's giving us a long signal. And that long signal is important because it's going to increase our capacity to make new protein. And then each time we eat after that, we're going to make even more protein than we would have normally. And it's interesting about our protein, and the reason that we tell people to eat leucine-rich protein is because leucine-rich protein activates mTOR, because leucine directly can activate mTOR through a series of events, because leucine was a limiting amino acid early in development. So very early in evolutionary time, we needed to know how much leucine was in our environment. If there was a lot, we could grow and then divide as a cell or as an organism. So leucine became a really important signaling molecule that said, okay, we've got lots of these building blocks. Now let's grow. And so the reason we look at leucine-rich protein is because the leucine-rich protein targets mTOR. The interesting thing is that as we exercise more and more, the mTOR signal actually goes down.
Oh, wow.
And it doesn't go down during the phase after the exercise or after eating. What it does is the baseline goes down. And so the first time we do a big resistance exercise bout, we're going to feel sore in a couple of days because of the immune response. And mTOR is essential to immune function. So that mTOR that we see in the muscle is probably a signal that the muscle was injured, now it's repairing. It's not necessarily a direct anabolic signal. It's just said we did a really heavy lift. We caused some damage. Now we're going to have inflammation. That needs mTOR, so mTOR activity goes really high.
Okay.
As soon as the second or third bout, if we looked at mTOR activity again, it would be much, much lower. And then if we go a few weeks out and we look at just a baseline at rest, our mTOR activity is actually much lower than it is before we started exercising. So what we're doing is we're increasing what we call the dynamic range. So what we're doing is we're bringing the baseline down so that every time I eat, now leucine comes in, I get this big response. So it goes from almost nothing to something high. Whereas before, I would go from, say, 50% to 100%. Now what I'm getting is say, 10% to 100%. So I'm getting a bigger signal, even though I'm starting from a lower baseline. It's what exercise tends to do. So inflammation we know is bad for us. Prolonged inflammation is going to give us things like diabetes. It's going to be associated with aging. It's going to do all of these things. But when we do exercise, we get this huge inflammatory response. And then what happens is it turns off and actually goes down below baseline. And it's really that baseline. Because when we lift, we're going to lift 2 to 3 times a week. People who are lifting, in your group maybe are going to lift maybe 20, 30 minutes each time, hour and a half during the week. Hour and a half out of a whole week is a very, very small amount of actual lifting. So the effect isn't during that lift or immediately after the lift. It's actually in that period of recovery and regrowth. And so what we're doing is we're decreasing the baseline so that every time we eat, we have a bigger effect. Every time we eat, we have a bigger effect. And so now we can signal a little bit better. And we see that with all kinds of exercise interventions. So if we have somebody who's got chronic inflammation, we put them onto endurance exercise. That exercise bout causes inflammation, but afterwards it comes down. And every time we do it, it comes down a little bit lower. And so the reason the exercise is healthy isn't necessarily just the exercise. It's the fact that we're decreasing all of these kind of slow rises that we get from living.
It's the adaptation to it over time, really. Mm-hmm.
Yeah. And the more we can turn those things off, the better. Because one of the important things we know about mTOR is, it's important in growth, but it's also negatively correlated with longevity. So one of the best drugs to increase your lifespan is a drug called rapamycin, and it blocks mTOR. And the reason that's important is because it decreases cancer and it decreases all these other things. So what we're doing when we do our endurance exercise is we can turn off mTOR. That means that now our mTOR is much lower. It's good for health. Now I'm going to do a resistance exercise, but I'm going to turn on mTOR, but then afterwards I'm going to turn mTOR lower than it was before. So the reason that these things are good for our muscles is because they turn on mTOR, allows our muscle to grow in the short term, but then it turns it off so that now what it can do is it allows the muscle to do other things that are really important for longevity. So when we lift the weight, we activate mTOR. When we eat leucine-rich protein, we activate mTOR. That's great. We're going to build more muscle protein. But in the meantime, mTOR is going to come down really low. And one of the things that's really important that happens for is a process called mitophagy, where we break down mitochondria and we get rid of the damaged mitochondria.
Oh, yeah.
So we can make better, fresher mitochondria. And so when we combine endurance and strength, we used to think that they were diametrically opposed. They can block each other, but it's not as big of an effect now because the way that we think it happens is that it decreases your sensitivity to protein.
Mm-hmm.
And when we really saw a big effect of endurance and strength coming together in what's called the concurrent training effect, the endurance was blocking your ability to get bigger and stronger. But that was at a time where we're eating 0.8 grams per kilogram body weight of protein.
Okay.
And now that we're eating much more protein, we don't see the effect as much. And Jose Herrera has done studies that shows that if you're in a caloric deficit, but you increase your protein intake, you still get as much protein synthesis. Ina Gardner had done a study for the Norwegian Institute of Sport where she put athletes on a big diet, but increased protein content in the diet. They're actually still able to grow muscle mass and strength. But we don't see the concurrent training effect as much, probably because the way that mTOR is inactivated by the endurance exercise is that the endurance exercise makes it harder for leucine-rich protein to turn on mTOR. Now that we've increased our protein content in our diet, we're seeing less of the effect.
Yeah. Yeah. And as you mentioned, like old school recommendations of having 0.8 grams per kilogram of protein. I mean, that really is low. And most people do a much better job at eating enough protein. And so, in fact, I very often, like many of my clients are eating certainly enough protein. And it's good though, like you were saying, because that way there, as you are endurance training, you can still build muscle. So that's, it's a good thing to focus on.
Yeah. And so it's also really interesting because even after endurance training, your protein synthesis rates go up. It's just doing it in a different way. So, and then, so this idea that you can't do them together. No, if you want to do them ideally, we still say do your endurance first in the morning. Because again, you get this, especially if you can do some of your training in the morning in a fasted state. Now you've got multiple different signals that are coming on. And John Hawley's done a bunch of work with overnight fasting training. So it's same amount of carbohydrate in the whole diet, but you don't have carbohydrate after, say, an afternoon training bout a couple of times a week. You then have a dinner that's mostly protein and vegetable. You go to sleep, you do your next training bout in the morning. And that training bout is going to have a bigger effect on performance because you're in this sleep low idea. Then what you do is you refuel, you come back up, and then we do your strength training later in the day. And we like to do our strength training right before dinner because the biggest protein meal of the day is your dinner. So then we don't have to do any supplementation either. We just change when we're going to do that training bout. If it's at like 5:00, you're going to go and eat dinner 6:37. That's going to give you plenty of protein. So I don't have to give you a supplement. I can give you just good food. And that way, if you've got people who are on a caloric budget, we don't have to change their budget. They can just change when they're doing their training.
When they do their workout. Yep. Really interesting. Well, Dr. Baar, this is an episode that I think I'm going to have to re-listen to a couple times to catch all the bits of science that you shared with us today. It was really insightful that between collagen, the mTOR pathway, and then the differences, throughout a woman's cycle with estrogen surges and our risk for injury. And just, like you mentioned, things in there about how we can have collagen or MSM or even the oral contraceptive pill to potentially, consider how you might be able to protect your body really and take care of it. So thank you so much for sharing all of this information and for doing the research that you do. The research, you mentioned something you're coming up with now. I think it was collagen, current research. So we'll keep up with that one.
There's plenty of things we're doing now with hormones and other things that we're really excited about. So yeah.
Yeah. Well, Dr. Baar, at the end of every episode, I actually ask all my guests the same questions. Are you ready to play along?
Absolutely.
Okay. If there is one food you could eat every single day for the rest of your life, but never get sick of it, what would it be?
Oh, geez. I don't have any one food. I tend to go with like a grilled meat and a salad, like a Mediterranean salad. Those are the things that I go for.
Mediterranean salad. That sounds great. What is your favorite sport to participate in yourself?
So I was a huge basketball player. I do love it,
Awesome.
But I don't get to play it as much as I like.
Yeah. But great. So how about as a spectator? Is it the same or something different?
As a spectator, now I like watching football, European football, so soccer.
Oh yeah.
My daughter played and then got me all excited about it. So now I'm doing that more.
That's awesome. All right. And as a female athlete nutrition podcast, if there's a female athlete out there that you think is inspirational, you want to give a shout out to, whether somebody well known or in your personal life, who would it be and why?
Well, there's just there's a huge number. So I'm a huge Chelsea fan. So I love the Chelsea women. I love Erin Cuthbert is a wonderful player. Sam Kerr is an outstanding. There's tons and tons of inspirational women. You get especially like the U.S. team and what they've done for bringing equal pay in. But I will have to say that my favorite female athlete, there's two of them. It's going to be my wife and my daughter. So
yeah. I love that. Always the most inspirational are the ones at home when you see them working hard every day. So
absolutely.
Well, wonderful for them. Shout out to Dr. Baar's wife and daughter for being awesome female athletes. And thank you for your research in exercise physiology and science and nutrition. And then also the more recent research on these hormone levels, because I think this is really so interesting where the nutrition field can go is looking at differences. Are there differences? And if so, what are they with nutrition across the different hormone levels that men and women experience? So thank you for doing this.
Absolutely. My pleasure. Thank you for having me.
I really hope you enjoyed that episode and thanks for listening. But before I let you go, I have free resources that you can have access to right away, right now, so that you can start fueling your body as a fierce, fit, and fueled female athlete. First, I have your Red S recovery race. If you've ever wondered if you might be struggling with Red S, curious to learn more, or know you have Red S and are looking to recover fast, then you can head to www.riseupnutritionrun.com/RedS and download the Red S recovery race. See how you place and figure out the next steps to recovery. Plus, while there, I have a few other great resources for you, including 3 nutrition secrets that every elite athlete swears by, and access to a private Facebook community, Female Athlete Nutrition. So again, to gain access to all of this, head to riseupnutritionrun.com/RedS. That's /REDS. And you can gain access and get the help you need fast. Too many girls and women and female athletes struggle with nutrition, but you don't have to any longer. Become fierce, fit, and fueled. Links in the show notes, and I'll see you next time.